In our previous video, we configured and set up our lab. We're now going to configure SSH connectivity between hosts. Ansible is an agentless architecture, and therefore for connectivity to take place between Ansible and our targets, a trusted relationship is required for automated, passwordless connectivity. What happens when we run SSH between a client and a server? If we look at the example here, I show that we're logged in as the Ansible user, and I've entered the command ssh ubuntu 1, i.e. open a secure shell from ubuntu-c to ubuntu 1. When we press return, the following will happen. An SSH session is requested. Both the server ubuntu-c and ubuntu 1 exchange the SSH protocol versions that they support. If they're compatible, they agree. Otherwise, the connection will be stopped at this point. Then a key exchange takes place with the cryptographic primitives that each side supports. After they've agreed on the cryptographic primitives, they negotiate a session key using the Diffie-Hellman algorithm. It's at this point where some of you who've used SSH before will see this familiar message where it's asking us to verify the target fingerprints. We accept this, and this is stored to the client's known host file. Now that a session is in place, new keys are exchanged between the client and the server, and going forward, both sides use the new keys. Finally, we have an encrypted session, and we're ready for authentication. And if you were to try this, we'd see a request for the password from the Ubuntu One system. Watch the Ansible Ubuntu icons carefully. On this video, I've given both the client Ubuntu-C and the server Ubuntu One a glow to indicate that connectivity is established. As we go through this video, when the icons glow in the same way, the server and client have completed the steps we've outlined and have established a secure connection. Note, at this point, they have not authenticated. They've just established a secure channel. We take a look and do this in our lab, and we enter here localhost :1000, and from here, we're going to choose the Ansible terminal. From there, select Ubuntu-C, and then we enter the username of Ansible and the password of password. We're now in the terminal of Ubuntu-C. Let's try opening an SSH connection to Ubuntu One. We accept the fingerprint. This will write this fingerprint to Ubuntu-C's known hosts file. We now have a secure channel and we're being asked for the password, so we're at the authentication stage. If you enter the password, which is quite simply password, we're now logged in to Ubuntu One. And if you type exit here, you'll go back to the Ansible host. Let's take a look at the known hosts file. SSH information is kept in a hidden directory called .ssh. The dot means that you won't see this with a standard ls, but if you were to list with all information, you would see this. We can then cd to change directory to this location, and if we do an ls here to list files, we can see our known hosts file. We can then use the Unix command cat to show the contents of this file. If you're new to Unix, it's called cat as it also provides the functionality to concatenate files. We're just using it to show files here. This at the moment doesn't appear to be too friendly, and we can actually see two entries even though we've only accepted one host key at this point. The reason being, when we accepted the fingerprint, it captured the fingerprint for both the host name and the IP address. We can prove this is the case by generating the fingerprint ourselves with the ssh-keygen command. If we do this firstly for the host name, we can see that this entry tallies up with the first entry. If we ping Ubuntu One to quickly get the IP address, and press Ctrl-C to exit, we can now run the same command against the IP address. And there, the second entry tallies up with the second line in the known hosts file. If we were to delete the known host file, then attempt to reconnect again, this would once again ask us to verify the fingerprint. We'll just accept the fingerprint and then press Ctrl+C, and now we exit from here. We've got a good understanding of SSH connectivity, so let's have a look at how this relates to Ansible, where we would like Ansible to be able to connect and manage our systems without the use of passwords. Ansible uses SSH, so to resolve this, we'll be implementing this at the SSH layer. What we just did with a password is an equivalent of the following. Our secure channel is established. We then enter the password, and this is sent securely through the channel to our target, Ubuntu One. And once it's validated, we have connectivity. But we don't want to be entering a password like this every time. So what we do is use SSH to create public and private keys, and then those keys can be used for access. We're going to talk through the theory, and then we'll do this in our Ansible lab for all of our hosts. On our Ansible control host, Ubuntu-C, we'll be creating a key pair comprising of a public and private key. On our target hosts within our .sh directory, we can utilize what is known as the authorized keys file, allowing us to add the public keys of our trusted hosts. With our secure SSH channels established, note the globe between our entities. When authenticating, the private key of Ubuntu-C will be used and is verified with the public key on Ubuntu 1, 2, and 3. As these tally up, our connection can now be established, hence we have green arrows. Let's put this into practice on our hosts. Let's log in again as Ansible, and we're going to use the ssh-keygen command. We can accept all of the defaults. We can now take a look at the generated files, both of which will be in the .sh directory. Firstly, let's take a look at the public key. You can see by the end that by default it's added the username of our host, which in our case is Ubuntu-C. This is the key we can share with others. The private key has the same name, but without the .pub on the end. We could technically copy the contents of the public key to the authorized keys file on a remote system. However, if we were to do this manually, we'd also need to make sure that the permissions of the authorized key file and the .sh directory are correct. Otherwise, SSH will reject it. There's a much more efficient way to do this. This is with a tool bundled with SSH known as ssh-copy-id. Let's use this to copy our public key to the remote system. The format is the username, in our case Ansible at the remote system. We enter the password of password, and this has copied our file. If we wish to, we could now SSH to the remote host listed using our private key, therefore no password prompt. For now, we'll just exit from this and go back to our Ansible host. You'll note we didn't get asked for the fingerprint, as we've already accepted this, but if we were to try another host, we enter yes to accept the fingerprint, and we enter the password, and this is now set up for our second host, Ubuntu 2. We want to copy our public key to all of our target systems as both the Ansible and root user. We could do this manually and enter yes for the fingerprint and type the password in each time for all of our hosts, or we could quickly automate this. Given that this is a course on Ansible and efficiency, let's automate to address the requirement for having to enter a password. We'll install the program SSH Pass. This is a Ubuntu system, so first, let's update apt using sudo. And if you're not aware of sudo, this means super user do. We enter our standard password, which is quite simply password, as this account is already configured with sudo access. Now their apt is updated, we can install SSH Pass. Brilliant. Let's create a password file called password.txt with our password in. We'll echo the password and redirect the output to a file. Let's do a series of for loops for the variations we need. We have 2 users we wish to target, Ansible and root, 2 operating systems, Ubuntu and CentOS, and 3 instances, Ubuntu 1, 2 and 3, and CentOS 1, 2 and 3. So first of all, we'll do both of our users. We'll do both of our operating systems. And we'll do all 3 of our instances. We're going to use SSH Pass with our file name. SSH Pass is used by prefixing the SSH command that you wish to target. In our case, this is SSH-copy-ID. We have the fingerprint aspect that we will also address. So here we will use the SSH option of strict host key check-in equals no to automatically accept fingerprints. Then we need to specify our combination, i.e. Ansible at Ubuntu 1 or root at Ubuntu 1. We use our variables here, so $user at $os followed by the instance. Lastly, we just need to close off each of our do's with a corresponding done. Okay, great. So we're done here at this point, and if you wish to try this out, you can now connect to any of your hosts as either Ansible or root. Before we go, we'll just clean up the password file. Now connectivity looks like the following. We can also do a quick test in Ansible and can check that Ansible can reach all of our hosts. We'll use the Ansible executable, which in an earlier chapter I mentioned was a fantastic tool for testing our configuration. We're specifying -i for an inventory, and with this parameter, you would typically specify an inventory file, but you can also use a comma to directly specify an inventory as part of the command line. We've put Ubuntu 1, 2 and 3 and CentOS 1, 2 and 3. Next is the word all, and this is the group of hosts that we wish to target. Any host in Ansible is automatically added to the all group, so this is a convenient way of linking in with all of the hosts we've specified on the command line. -m specifies the Ansible module, and here we're using a convenient module called ping that attempts to connect to a host and will return a pong if it's successful. Let's give this a try. Beautiful. So this is looking great, and our Ansible lab is taking good shape. We're going to remove our known hosts file, as subsequent videos show how to deal with this behavior in a way more aligned to Ansible. Join me in the next video where we'll be setting up the course repository.